Good day, learners. In this video, we are going to look at the analytical geometry questions from the November 2015 question paper, question 3 and 4. You'll see very typically there's two questions. The one is more aimed at grade 10, 11 work, and the other one is more aimed at grade 12 work. This is very typical. Let's jump in. Question 3. It says, in the diagram below, the line joining Q, there's Q, and P, there Q is -2, -3, and the point P is not given, it's AB, so there's missing coordinates. A and B is bigger than 0, both positive values. This line makes an angle of 45 degrees there with the positive x-axis. QP is 7√2 units. That's not given on the sketch there. So just remember that there is 7√2 units. And then the point N71, there it is the midpoint of PR. So it's shown there on the sketch that those two lines there are equal. And M is the midpoint of QR. So M is the midpoint of QR, so that those two lines there are equal in length. First of all, determine the gradient of PQ. Okay, now the gradient of PQ, gradient normally I need 2 points, I don't have, but I have the angle of inclination, and I know very well that question 3.1, the angle of inclination works with the gradient is equal to tan theta. This is on your formula sheet as well, and that theta is given to me as 45, and by special angles I actually know that tan 45 is 1, but you are more than welcome to just use your calculator for that as well. Because I'm not busy with trigonometry, I'm busy with analytical geometry. Okay, so the equation of Mn in the form y is equal to mx plus c and give reasons, which is a bit unusual, but they say give reasons, then I must give reasons. So the equation of Mn. Now, the equation of Mn is going to be the same gradient as that one. I hope you immediately know why, but it's because of the midpoint theorem. The midpoint theorem says if one line connects the two midpoints of two lines of a triangle, then two things. It will first of all be parallel to the third side of the triangle. So since I know from the midpoint theorem these two lines are parallel, parallel lines have the same gradients. And the midpoint theorem, I just want to finish that, says two things. First of all, it will be parallel, and second of all, this length would be exactly half the length of that one. Okay, great. So, since I have parallel lines, if I want to calculate that, I can say that the gradient of line MN is equal to 1, which is also the gradient of, come on. I just want to quickly refocus the camera here. Let's say, okay. The gradient of line MN is 1, which is exactly the gradient of that line. And I can say there MN is parallel to PQ because of the midpoint theorem. Midpoint theorem. Right, and then Mn on this sketch goes through the point 7,1, so I can now use y is equal to m, which is 1, x plus c going through the point 7,1 and substitute that in there. So to get my c, so the c is -6. Right, so that equation is then y is equal to 1x minus 6. Okay, the next thing is calculate the length of MN. Now, as I said, from the midpoint theorem, the gradients are the same because it's parallel lines, but also MN will be exactly half the length of PQ. This is more of a Euclidean question than analytical here. But okay, MN will be half the length of PQ also because of the midpoint theorem. Midpoint theorem, right? And PQ is given as 7 root 2. 7 root 2. So that is then going to be 7 root 2 over 2. I'm just going to leave it like that for now. Question 3.4 says calculate the length of RS. It's this one there. Okay, I have no information whatsoever. I just want to quickly check. PIB makes an angle with a positive. Any 7,1 PR is the midpoint. M is the midpoint. I have no information because I sort of want to check that this is not maybe a reflection of that. And so I just read through that information again. But this is most definitely, I have no information that this is an extension of that in any way, or that this is a parallelogram or anything like that. So the length of RS, my feeling is that it should be exactly that length, that this is a parallelogram somehow. Can I maybe prove that this is a parallelogram? Properties of a parallelogram are that opposite sides are equal, which I want to use, I don't have. Opposite sides are parallel. The diagonals bisect one another, which I don't have information that N is the midpoint of QS, do I? I suppose that should be a reflection. I don't know why it's a dotted line like that. And my inkling is to just say that it's 7 root 2. What is the marks here is just 1. I'm going to say that 3.4. I'm not 100% sure here. I'm going to say that RS is just 7 root 2 because I'm going to assume that this dotted line is a reflection of that, making this actually a parallelogram there. And that would be equal and that would be equal. But I just want to quickly check. Just give me a second here. You can skip forward a little bit in the video if you want. I just quickly want to check the memo here. The November 2015 question 3. What did they say there? Question 3.4. No, this is 3.5. The length of R is. They did indeed assume that is a parallelogram. The information was not given though. I'm a bit upset with that. That's a bit unfair to me. And actually 3.4 is missing from the memo. But I can see okay. I can see the expectation is that you should, but they should have said this is a reflection or something so that you know that that is a parallelogram. But okay, I can see they did assume that that is a parallelogram, making RS then 7 root 2. So that's fine. Question 3.5 says the coordinates of S such that PQ or S in this order is a parallelogram. You also see okay. Yeah, that's a bit weird. The coordinates of S such that PQ or S is a parallelogram. Now, if this is a parallelogram, typically a parallelogram, the diagonals bisect one another, so the length also from there to there should be the same as the length from there to there, meaning in analytical geometry terms, this is the midpoint of these 2 points. I have the midpoint, I have the 1 point, and I can use that to calculate the coordinates of the other points. So what's going to happen here is the midpoint of SQ should be XS plus XQ over 2 and YS plus YQ over 2, which I have the X and Y value of Q, which is -2 and -3. I don't have XS, but XQ is -2 and YQ is -3 over 2. And then the midpoint is, it's given here as 7, 1, 7, 1. Right, so this XS minus 2 over 2 should be equal to 7, and the YS minus 3 over 2 should be 1. This should be 1, right? And then you have two separate little equations with a x and a y to solve. So I can do that, multiply by 2, then I have the xs minus 2 is 7 times 2 is 14, and jump the 2 over, so the x coordinate of s is 16, and solve here same way. Ys minus 3 is 2, multiply by 2, and then jump the 3 over. Ys is 2 plus 3, which is 5. So the coordinates of s is then going to be 16, 5. Okay, coordinates of s 16, 5. I think they should have actually asked this question maybe then as 3 point, this is 3.4 and this is 3.5, maybe. But okay, never mind, we got there. And then 3.6, the coordinates of P. So there is P. You can do the same thing on this side if you had the coordinates of R, which you don't. Or then to calculate the coordinates of P, I think I can use the fact that I have this distance there with this point, but then that's going to give me 2 missing values. So that's one equation I can use with 2 missing values. Or I can maybe use the gradient formula with A and B, and then the gradient of this is 1. But then also that's an equation with 2 missing things. and then I can do simultaneous equations. Let's just see what this question counts. Well, 6, yeah, so probably that's something that I can do. So let's jump into that. What I can do to calculate the coordinates of P is I'm going to use both the distance and the gradient formula. So the distance of PQ is 7 root 2, and I have Q, which is -2, -3. Length of PQ is root of xp minus xq squared plus yp minus yq squared, and I have the coordinates of P, which is AB, that I want to calculate, and the coordinates of Q, which is -2, -3, and I have this distance as 7 root 2, okay, is equal to root xp is now going to be a minus -2, so a plus 2, over yp is b minus -3, which is then plus 3. Just to get rid of this roots, let's just square both sides. So if I take this square, the 7 squared is 49, and the root 2 squared is going to be 2, and then I'm rid of this square root, so I have a plus 2 squared plus b plus 3 squared, and 49 times 2 is 98, I suppose. 98, yes. Okay, so this is 98 is equal to, and I'm going to multiply these two brackets, a plus 2 times a plus 2. If you need to write both, you do that. It's a squared plus 4a plus 4 plus, and same thing here, b squared plus 6b plus 9, and then well, I'll stop there for now. I'm going to do simultaneous equations, and maybe if I substitute, it will make it easier. Maybe I can just add the numbers all together. So I have a squared plus 4a plus b squared plus 6b, and then I have on this side 9 plus 4, 9 plus 4, subtract the 98, so minus 85. Okay, so yeah, that's my one equation in terms of a and b that I have. The other equation that I can get here is by taking the gradient of PQ, which is difference in y. B minus -3 is going to be b plus 3 over a minus -2 is going to be a plus 2, which the gradient is now, I calculated the gradient is most 1. So 1 is equal to b plus 3 over a plus 2, and if I simplify this a little bit, multiply the a plus 2 with 1, it's going to be a plus 2 is equal to b plus 3. So a is equal to b plus 3 minus 2 is plus 1. Okay, this is a lot simpler than that, at least. Okay, so I have the two equations here that I want to do simultaneous equations with. A is b plus 1, and the other one is a squared plus 4a plus b squared plus 6b minus 85 is 0. So a is b plus 1. That a b plus 1 squared plus 4a is b plus 1 plus b squared plus b squared plus 6b plus 6b minus 85 is 0. And now I also must now multiply out this and simplify. Okay, so this one again, b plus 1 times b plus 1, so b times whatever, you do that. If you need to write that out, plus 1, 4b plus 4 plus b squared plus 6b minus 85 is 0. Add the like terms, so I have b squared plus b squared, I'm just going to cancel them as I add them, is 2b squared. 2b plus 4b is 6b, plus 6b is plus 12b, and 1 plus 4 is 5, minus 85 is minus 80 is 0, and I can divide this by 2 throughout, so it's b squared plus 6b minus 40. Okay, and 8 times 5 is 40, which is not going to give me 6. 4 times 10. Okay, so I can factorize this. But if you don't feel like listing all of the factors of 40 and you don't find one fast that gives you 6, I just want to double check quickly. Plus 10b minus 4b minus 40. Okay, that works. So b is negative 10 or b is 4. Okay. You can always use the quadratic formula as well, so you don't waste time now on factorizing. Now, if I think of the question in the beginning, they said to me that the a and the b is both bigger than 0. So this negative here is not applicable. The b, since the b is bigger than 0, I only have b is equal to 4. That's going to work. Negative not applicable, so a is b plus 1, which is 5. Right, so I have the coordinates of p as ab, which is then 5, 4. Great. This was fun. I hope you enjoyed this as well as much as me. This is really I mean, this is not crazy difficult, it's just long. Wow, there must be a shorter method, or there could be a shorter method. I tend to opt for longer methods a lot of the times, or the complicated methods. Sometimes I just make things more difficult than they should be. Okay, and then question 4. This is now your typical grade 12 question. Says, in the diagram below, Q52 is the center of the circle that intersects the y-axis at 0, 6. And S. So 0, 6 is a point of intersection, and also S, which I don't have the coordinates. The tangent APB, so this is a tangent, great. At P intersects the x-axis at B, and it makes an angle alpha with the positive x-axis. R is a point on the circle there, and PRS is theta. PRS, that angle there is theta. Okay, right. Determine the equation of the circle in the form, standard form. Right, how they should be. Now this one is not too difficult since I have the center of the circle already, which is the AB. I only need the R, which is not difficult to calculate because I have that 2 coordinates there, that I can just use the distance formula to calculate the length of this radius. So I'm going to start with that. Question 4.1. The radius of the circle is going to be, I'm going to use distance formula with P, that point is 0, 6, and Q, the center of the circle, is 5, 2. Alright, just to show you again, there's P, there's Q, so that is 0, 6, and that's 5, 2. And I'm going to write here difference in X, 5 minus 0 squared, plus difference in Y, 2 minus 6 squared. And I'm going to quickly just type this into my calculator. I get root 41. Okay, so the radius is root 41. Then my equation of my circle, this is the center, is going to be x minus 5 squared plus y minus 2 squared is equal to radius, which is root 41 squared, and then that is what it looks like. Just to quickly write down the standard form there for you as well. So the standard form is x minus a squared plus y minus b squared is r squared. The a, b is the coordinates x, y coordinates of the center of the circle. So x, y of the center of the circle 5 and 2 is my a and b. And the r is root 41, but in the equation it's squared. So that's why I have 41 there. That's 4.1. Question 4.2, calculate the coordinates of S. Okay, so if I have the equation of the circle, to determine y-intercepts, S is a y-intercept, I'm going to make x 0. And it's going to give me two answers, 6 and something else that I need here to find the coordinates of S. Is one thing you can do. I'm going to quickly discuss something else you can do. I predict it's going to be 0, -2. But let's quickly check. So there's my equation. To get y-intercepts, I'm going to make in this equation, make the x 0, right? To get y-intercepts, make the x 0, and then I'm going to solve this. So I have 5 squared plus, if I multiply out y minus 2 times y minus 2, it becomes y squared minus 4y plus 4 is equal to 41. So y squared minus 4y plus 4. I actually should somehow add all of these numbers, but okay, plus 4 plus 25, the 5 squared. -5 squared is positive 25, yeah. Minus 41 is 0. And let's just quickly add that 4 plus 25 minus 41 is -12. So my standard form y squared minus 4y minus 12 is 0. And well, I can easily factorize this. Y minus 6y plus 2 is 0. So y squared minus 6y plus 2y minus 4y minus 12. So y equals 6 or y equals -2. Did I not tell you that? Okay, so that means then this is now the coordinates of P is 0, 6 that was given to me, and then S, which is what I wanted to calculate here, is the coordinate 0, -2. Let me quickly just tell you how I knew that. There the coordinates is 6. The center of the circle is at 5, 2. So if I place that 2 here, that's the center of the circle. Obviously a circle is symmetrical, so those two coordinates should be the same distance there from the center of the circle. So if I draw a line here that's parallel to the x-axis, that value there on the y-axis is going to be 2, right? So from 6 to 2, that was 4 units, and then from 2 to -2 is 4 units again. So that's what I did there to predict the answer. Okay, question 4.3, determine the equation of the tangent APB in the form y is equal to mx plus c. Have I not told you this is something that you see quite often? Okay, so question 4.3. I have the coordinates of PQ. I want to now determine the tangent at P, right? So Q is the center, Q is the center, P is that point of tangency. I have the coordinates here. So I want to calculate the gradient of this, and from that perpendicular I get the gradient of the tangent, and then substitute the gradient of the tangent with this point P to calculate the equation of the tangent. This is a question you see quite often. So 0, 6, 5, 2. I want to calculate the gradient of PQ, which is the radius, right? So it's difference in y, 6 minus 2, over difference in x, 0 minus 5. and then this is negative 4 over 5, and I'm just going to double check that with my calculator. Especially when you're in an exam, even if you normally do mental calculations quite good, especially in an exam situation, just double check yourself with a calculator, because we do make silly mistakes when we're under stress and tired from exams and all of that. Okay, so the gradient of PQ, then the gradient of APB, which is the tangent, APB, times the gradient of the radius, which is negative 4 over 5, should be negative 1 because a tangent is perpendicular to a radius. And then negative 1 divided by negative 4 over 5, the gradient of APB is positive 5 over 4. And then I'm going to substitute into my straight line equation. If you use the other form of the straight line equation, that y minus y1 is equal to mx minus x1, that's perfectly fine. I prefer this one. Through the point of tangency 0, 6. So I'm going to make x 0, y 6, and m 5 over 4 in this equation. Y is 6, m is 5 over 4, x is 0 plus c, and then this becomes 0, so well, c is 6. Okay, so y is equal to m5 over 4x plus c, which is 6. There's the equation of my tangent. Okay, and 4.4 says calculate the size of alpha. Alpha is the angle of inclination of this line, so it's exactly where the angle of inclination should be. So that's not very difficult. The angle of inclination tan alpha is equal to the gradient. So I want to calculate the alpha. So alpha should be shift the tan of the gradient of that tangent, which I calculated already as 5 over 4, 5 over 4, and then that's going to produce shift tan alpha. That's going to produce my alpha, 51.34. There we go. Right. 51.34 degrees. Right. Question 4.3, 4.5, sorry, I'm now counting backwards here. Calculate with reasons the value of theta. Okay. Right. So now you can jump in. Theta is definitely not an angle of inclination. So maybe I can work with, there is an angle of inclination. Maybe I can work with that. Or I now have this alpha, and I know this is a tangent. I can use my Euclidean theorems, all of them. Exterior angle of a triangle, tan chord theorem, anything like that. There's a tangent, so I can maybe use tan chord theorem. The tan chord theorem says that the angle between a tangent and a chord is equal to the angle on that chord. So this theta is actually also equal to this one. These two are equal because of tan chord theorem. This is the x-axis, which has a 90 degree. I have alpha, and that can produce theta for me there. So I'm going to do that. BPO, right? Angle BPO is equal to theta because of tan chord theorem. Normally in analytical, I wouldn't really bother too much with reasons, but because they said now with reasons, then I must now do it. So BPO is theta, and then alpha plus theta plus 90 degrees is going to be 180, because of sum of angles of a triangle. And then I know mos now alpha is 51, so that makes theta equal to 180 minus 90 minus the alpha 51.34, and that gives me theta is 38.66 degrees. And this actually 4 marks. 4 marks for this little work. That's great. Okay, and then the last question here before we end this video, question 4.6. Calculate the area of triangle PQS. PQ, where's Q? Oh, there. PQS. Okay, PQS. So, I mean, I think the easiest thing to do here to calculate the area of a triangle, you can use the area rule from trigonometry. But if you can find that's not necessarily 90 degrees, né? But if you can find a base with a perpendicular height on it, it's ideal to just work out the area of a triangle with half base times perpendicular height. Now quickly look at this. This length here, I know it goes from 6 to -2, so this length here, PS is 8 units, right? 4.6, PS is 8 units, right? Because it goes from 6 to -2. The difference in y there, or vertical lengths I just get by difference in y, 6 minus -2, so 8 units. And then the length there perpendicular to this, so that I have half base times perpendicular height. The perpendicular length there, don't be tempted to say it's the radius, just check for the radius, you need it to actually go to there. Don't get confused, it's not the radius, but the perpendicular length there, if I keep my y value at 2, it's going to make it a perpendicular length there of 5 units. Great. Okay, so that length there is 5. The perpendicular height on PS is 5. So the area of triangle PQS is going to be half base 8 times perpendicular height 5, and that is 20 squared units. There we go. Okay, and that's the analytical questions of the November 2015 paper. This was really not too rough, I hope. I actually enjoy the analytical a lot. I hope you do too. And yeah, good luck with lockdown. Good luck with lockdown. Okay.